Hey everybody, CBQ here with a special edition of How It Works. We're here at the Software 2.0 Field Day. I'm here with Lucas, one of our senior software robotics engineers. We got mowers in the background, so apologies for the sound, but we're here to talk about two new features that you and your team have been working on, so thanks for being with us. One of them is the new state-of-the-art model predictive controller. Tell us in kind of layman's terms, what does that mean? What does that mean for our turns? How does that work? What is a model predictive controller?
Sure. So yeah, what the mower is doing is it's looking ahead about a second or two along the path that it's supposed to be driving, and it's simultaneously calculating the control inputs for the mower along the entire second or two of the path, taking that first one, using that to drive along the path, and then recalculating at a very high frequency.
So that makes sense. I mean, a lot of times people will think about what we're doing. They think, we pre-program these turns almost like a CNC machine, like turn this wheel, turn that wheel. We are not doing that. Our mower is taking into a lot of sensors. I guess one of the questions people have is what is it reading? Like it starts the turn, it ends the turn. How does it know? What sensors is it reading to know it's done with the turn?
Yeah, so we're taking all the data from our localization systems. That's GPS, IMU, wheel odometry. That's all getting fused, and then we're taking that and looking at our mower heading, our orientation along our path, and then where we are along that path, and recalculating our control to keep us on the path as best as possible.
Awesome. So I know another feature that you've done is we've called it before a just-in-time planner, and it has to do with when obstacles are near the boundary. The mower would sometimes go up to them and do kind of a let's call it janky before turn because it was trying to avoid that obstacle. You've done something different with the just-in-time planner to help beat obstacles at the sort of end. Tell me a little bit more about that. What does that do?
Yeah, so now when we see obstacles close to our boundary, we'll identify those and we'll shift our Y-turn in from that boundary. So rather than performing that kind of jiggly path to get around the obstacle, we'll just shift that Y-turn in, drive a nice smooth Y-turn, and avoid the obstacle.
Nice. And so as a reminder, we inflate those obstacles. So you're right, you could go in and you'd almost see it kind of do a mini arc. And instead now it performs more like a human. A human's like, hey, there's something there. I'm just going to do my standard Y-turn, non-rutting turn right there. So that's pretty cool. Well, great work. Any challenges or things you want to improve? I mean, our audience always wants to know, how do we get better?
Yeah, there's always bits and pieces to improve. Certainly more tuning on the controllers in general, on the Y-turns, getting those Y-turns even smoother, faster, removing any hesitation whatsoever. That's goals.
All right, well, you got your work cut out for you. Thanks for your work on this. All right, let us know in the comments if you have any questions on what you want to see us talk about next. Thank you.